Hello everyone, welcome back to my YouTube channel. So for this week, I'm going to explain to you how you should answer test 2 questions. Altogether we have 6 different questions, and let's start with the first one. Question number 1. The acid dissociation constant Ka of a 2.5 liter weak acid has a value of 2.56 times 10 to the power of negative 4. Determine the pH of 1.0625 times 10 to the power of negative 2 mole of the weak acid. The first thing that you need to do in order to answer this question is to be able to write the ice diagram. So let's do the ice diagram together. Right, let's do the ice diagram. So we shall start with the balance equation for the dissociation for weak acid. So we have Ha, which shall be dissociate to H plus and also A minus. So Ha, H plus and also A minus. So this is the ice diagram. But please do understand that in your ice diagram, you need to be able to write the molarity instead of the number of mole. So the molarity is equivalent to mole over liter. So the number of mole given to you in the question is 1.0625 times 10 to the power of negative 2 divided by 2.5 liter. So that one you will get 4.25 times 10 to the power of negative 3 molar. Right. So the next thing that you need to do is you need to plug in this value inside the ice diagram. So I'm just going to write 4.25 times 10 to the power of negative 3. So at the beginning of the dissociation, there's nothing being dissociated, so 0 and 0. So at change will be negative x, positive x and positive x. At the product shall be positive x because the product shall be produced, and at the reactant is negative x because it is being dissociated to the product. So at equilibrium, it's the same thing. It's going to be 4.25 times 10 to the power of negative 3 minus x. So 0 plus x equivalent to x, and this one is x as well. Okay, from the ice diagram, what we can write is the Ka. So Ka is equivalent to whatever in the product, which is the H plus times the A minus divided by whatever in the reactant. So mind you, it should be a box bracket because it should be in concentration. So we can simply write it again as x squared divided by 4.25 times 10 to the power of negative 3 minus x. So in the question given to you that the Ka is equivalent to 2.56 times 10 to the power of negative 4, means that you already know the value of your Ka. So at the moment you are going to find what is the value of x. Right, so the value of your Ka is 2.56 times 10 to the power of negative 4. So this shall be equivalent to x squared divided by 4.25 times 10 to the power of negative 3 minus x. So what we are going to do now is we are going to approximate. So we are going to remove the x around here. So you should get 2.56 times 10 to the power of negative 4 equivalent to x squared divided by 4.25 times 10 to the power of negative 3. Alright, so from there what you're going to do is you're going to rearrange this equation, and you shall get your x squared is equivalent to 2.56 times 10 to the power of negative 4 times 4.25 times 10 to the power of negative 3, which will bring you to this. X shall be equivalent to the square root of 1.0880 times 10 to the power of negative 6, giving you your x is equivalent to 1.0431 times 10 to the power of negative 3. So I'm just going to recap a bit. Here we are doing the approximation. So since we are doing the approximation, we need to evaluate whether the value of x that we get is correct or not. So we need to do the test check. So test is equivalent to the value of x that we have. So this is 1.0431 times 10 to the power of negative 3 divided by the initial concentration. So the initial concentration we get 4.25 times 10 to the power of negative 3, which is the number of mole divided by the volume. So from here, when you press your calculator, you should be able to get 24.543. So this is obviously too big because we need to get less than 5%. This is way more than 5%. So we need to find the new value of x. How are we going to do so? So you need to remember the first time when we want to find the value of x, we are using the approximation method. In the approximation method, the x that we have here, we simply remove it. But now, since the test we get is more than 5%, what we are going to do is we are going to substitute this value of x inside the x that we initially remove. Alright, so let's find the new value of x. So the Ka given to you in the question is 2.56 times 10 to the power of negative 4. Therefore, is equivalent to x squared divided by the initial concentration, which is 4.25 times 10 to the power of negative 3 divided by x. So initially when we calculated just now, the value of x is equivalent to this one. So we are just going to substitute this into this x. So what we shall get is equivalent to x squared divided by 4.25 times 10 to the power of negative 3 minus 1.0431 times 10 to the power of negative 3. So what you are going to get here is your x squared. So your x squared should be equivalent to 8.2097 times 10 to the power of negative 7. So you're going to do a square root of that. So you will get your x should be equivalent to 9.0607 times 10 to the power of negative 4. So this is the new value of x. You don't have to do the test again. We're just going to use this value as it is. Alright, so looking back at your ice diagram, so you know that this is the ice diagram, and from the calculation we get your x. The new x is equivalent to 9.0607 times 10 to the power of negative 4. In the question you were asked to determine the pH. So in order for you to determine the pH, you need to know what is the concentration of your H+. So the concentration of H+ is actually equivalent to the value of x. So now we are going to write the pH. So pH is equivalent to negative log the concentration of H+. In this case, the concentration of H+ is equivalent to x. So it's going to be equivalent to negative log 9.0607 times 10 to the power of negative 4. Therefore, you will get the pH of this weak acid equivalent to 3.0428. So this is the final answer for the first question. Let's move on to question number 1b. Reaction between nitrogen gas and hydrogen gas was conducted at 47.2 degrees Celsius. The reaction proceeded as follows, with KQ equivalent to 0.105. Briefly classify the direction of the reaction when 1. Reaction was carried out at the indicated temperature, and 2. The volume of the system is being decreased. Let's recap the theoretical part of the equilibrium constant. When your KEQ is bigger than 1, it shall favor the forward reaction. But if your KEQ is less than 1, therefore it shall favor the reverse reaction. In this question given to you, the KEQ is equivalent to 0.105, which is obviously less than 1. Hence, if the reaction was carried out at the indicated temperature, which is 47.2 degrees Celsius, it shall favor a reverse reaction. Let's do the part 2. The volume of the system is being decreased. So according to the theory, if the volume decreases, it means that the system shall move to the direction with fewer mole of gas. Right. So in this question, the reaction is between nitrogen gas and also hydrogen gas. So nitrogen is 1, hydrogen is 3, 3 plus 1 equivalent to 4. And the product is ammonia, so you have 2. So 3 plus 1 equivalent to 4. So definitely it shall move to the right, whereby it have a fewer mole of gas. Let's move on to question number 1C. The reaction between carbon and carbon dioxide occurs in accordance to the reaction below. The partial pressure of carbon dioxide and the total pressure of the gases are 2 atm and 6 atm respectively. What is the Kc of this reaction if the reaction is conducted at 27 degrees Celsius? Let's see what kind of information is given to us. So we were given the balance equation, which is carbon reacted with carbon dioxide will produce carbon monoxide. So it means that the total pressure is actually looking at the carbon dioxide and also carbon monoxide. And the partial pressure for the carbon dioxide is equivalent to 2 atm. Therefore, from here we can actually find what is the pressure for carbon monoxide. So total pressure is equivalent to the pressure for carbon dioxide plus pressure for carbon monoxide. So given to you, the total pressure is 6 atm and the partial pressure for carbon dioxide is 2 atm. So this one will be X. So X is equivalent to 6 minus 2. So you get your X is equivalent to 4. In saying that, the partial pressure for carbon monoxide is equivalent to 4. In this question, although you were asked to calculate the Kc, but you were not given enough information to calculate it. So instead, we should be calculating the Kp. So Kp is whatever in the product. So pressure of carbon monoxide to the power of 2, because you have 2 around here, divided by whatever in the reactant. So pressure of carbon dioxide, because carbon dioxide is just 1, so it's just 1. So why don't we consider carbon? Because carbon is in solid form, therefore we don't need that. So from the calculation just now, the partial pressure of carbon monoxide is 4, so 4 to the power of 2, and from the question you know that the partial pressure of carbon dioxide is equivalent to 2. So you shall get your Kp equivalent to 8. Alright, let us recall what we have calculated just now. So given in the question, the partial pressure of carbon dioxide is equivalent to 2 atm. And you have previously calculated the partial pressure of carbon monoxide, which is equivalent to 4 atm, and also you already calculated your Kp is equivalent to 8. So from here we are going to move forward to calculate your Kc. So Kp is equivalent to Kc RT to the power of delta N. So now we are going to calculate what is your delta N. So delta N is whatever in the product minus whatever in the reactant, provided that these things are in gaseous form. So In the product, you only have 2 carbon monoxide minus in the reactant we only have 1. So 2 minus 1 is equivalent to 1. So now what you need to do is you just need to plug in the values, because the T is given to you in the question, which is 27 degrees Celsius. But since your R constant, R is equivalent to 0.0821. So this one, your T should be in Kelvin. So your T should be equivalent to 27 plus 273. So it should be equivalent to 300 Kelvin. Right, so let us plug in the value. So your Kp is equivalent to 8 and your Kc is the one that you want to calculate. R is equivalent to 0.0821 times 300 Kelvin. And your delta N just now is equivalent to 1. So I'm just going to write that again. So 0.0821 times 300 to the power of 1. You should be able to get your Kc is actually equivalent to 8 divided by 24.63. So you will get your Kc equivalent to 0.3248. So this is the final answer for question 1C. Let's move on to question number 2A. 0.2963 gram of copper was deposited at cathode after undergoing an electrolysis reaction. The electrode was immersed in copper sulfate solution throughout the reaction. Determine the amount of current flowing through the wire during the 10 minutes reaction. Since you were given the mass of the copper which is deposited at the cathode, therefore we can actually calculate the number of mole. So number of mole is equivalent to mass over RMM. So the mass is given to you in the question is 0.2963. And from the table you can find the RMM for copper, which is 63.546. Therefore, you will get the number of moles of copper that is being deposited at the cathode is equivalent to 4.6627 times 10 to the power of negative 3. So what's next? We need to look at what really happened at the cathode. So it should be some ion lingering around so that it can be deposited to the cathode as the solid copper. So in saying that, we can write the half reaction at the cathode, which is equivalent to copper 2 positive plus 2 electron to produce copper. Right? So from here, actually we can predict what really happens at the cathode. Means that to produce 1 mole of copper, you shall need 2 electron. We can also write it this way: 1 mole of copper shall need 2 Faraday. But we have less than 1 mole, so we have 4.6627 times 10 to the power of negative 3 mole of copper. So this value 4.6627 times 10 to the power of negative 3, you need to times 2. Therefore, you should get 9.3254 times 10 to the power of negative 3 Faraday. So what else should we do? We need to be able to convert this Faraday. So always remember, 1 Faraday is equivalent to 96,500 coulomb. Alright, so since we already have 9.3254 times 10 to the power of negative 3 Faraday, we need to convert this to coulomb. So 96,500 times this value 9.3254 times 10 to the power of negative 3. So you should be able to get 8.9990 times 10 to the power of 2 coulomb. Right, so from here, then only we can know what is the current flowing, because when we get the coulomb, the thing that we get is actually the value of Q. Alright, now from this value, we can actually use it as Q equivalent to IT, where T is time and I is the current. So the value of Q is equivalent to 8.9990 times 10 to the power of 2. So equivalent to I, the thing that you want to calculate, and T, time. Given to you, time is 10 minutes. So remember that we need to always convert this into second. So 1 minute is equivalent to 60 seconds. So equivalent to 8.9990 times 10 to the power of 2, this one divided by 600, so you will get the value of I. Therefore your I should be equivalent to 1.4998 ampere. So this is the final answer for question number 2A. Question number 2B. An electrolysis process was carried out by using silver electrode and aqueous argentum nitrate solution as the electrolytes. Number 1. Illustrate the electrolysis setup for this reaction. Alright, the clue here is it is an electrolysis process. Therefore, if you were to illustrate the electrolysis setup, the first thing that you need to understand that electrolysis process need a cell or needs an external energy. So you need to draw the cell. So this one, you need to attach it with the electrodes, and you need to have the solution or the electrolytes. So here is your electrolytes. So what else did you need to do is you need to be able to label it. So here it says here that the electrolytes is actually aqueous argentum nitrate solution, right? So AgNO3, and here the electrodes are both silver, so argentum. This one is also argentum. So, and then how are you going to read this is the longer one is actually the anode, so this one is positive, and the shorter one will be the cathode, which is the negative. So this is the answer for the first part of this question. Let's move on to the second part of the question. Provide the half cell and the cell notation for the reaction. So you know that it is an electrolysis process. So we shall have the anode cathode overreaction, and then only we'll write the cell notation of the reaction. In this reaction, we are only dealing with the silver electrode and also the aqueous argentum nitrate solution. So argentum nitrate solution is equivalent to the AgNO3, right? So we know that argentum is plus and O3 is minus. So we know that the amount of electron that is going to take part in this reaction shall be 1. So in anode, where the oxidation occurs, so we have argentum minus electron, you will produce the argentum plus. And cathode, red cat, shall be undergoing reduction. Reduction always happen at cathode, red cat. So we have Ag plus electron, you will have your Ag. So the overall reaction shall be the Ag plus Ag plus shall produce Ag plus Ag. Apart from the half cell, you were also asked to write the cell notation. So when you want to write the cell notation is anode cathode. Right, so how are you going to write it? So at anode, it starts with Ag, so the argentum shall be in solid form, and then it shall turns into ion, and then you will divide it with these dots, and then at the cathode you will have your Ag plus slash your argentum, which is in the solid form. So this one you can also write in aqueous form. So this is your cell notation for the reaction. Let's move on to the final question for this test, question 2C. A cell is prepared by dipping a copper rod in a 0.01 molar copper sulfate solution and zinc rod in 0.02 molar of zinc sulfate solution. The standard reduction potential of copper and zinc are positive 0.34 volt and negative 0.76 volt respectively. Calculate the cell potential, E cell, for this reaction. Alright, in this question you were given the standard reduction potential for copper and also zinc. So when you have the standard reduction potential, you need to look at the more positive value. The more positive value means that it shall be at cathode, whereby in cathode is red cat. So reduction always occurs at cathode. So in this question you have copper and also zinc. So the standard reduction potential for copper is positive 0.34, whereby the standard reduction potential for zinc is actually negative 0.76. So obviously copper is more positive, therefore it shall be at cathode and it will undergo reduction. Alright, so let us start with writing the half reaction. So as we know, because the copper is more positive, therefore it shall be located at cathode, which shall undergo the reduction process. So standard reduction potential. So we are not going to change anything with the E note for copper. So we're just going to write positive 0.34 over here, and it shall undergo reduction process. Therefore, we are going to write it as Cu2 plus 2 electron, which shall produce copper. Right, next up is zinc. So zinc is going to undergo a oxidation process, therefore it's going to be zinc minus 2 electron to produce zinc 2 positive. But if you look at here, it is negative 0.76 volt. But this is a standard reduction potential since we already make it into oxidation. So from negative we change it to positive 0.76 volt. Therefore we can write the overall reaction as zinc plus Cu2 plus will produce Zn2 plus Cu. So what is the value here? So the value here is just a summation of this, so you should get positive 1.10 volt. In other words, we can say that the E node cell is equivalent to 0.76 plus 0.34. Therefore, you will get positive 1.10 volt. Alright, but in the question you were asked to find the E cell instead of E node cell. So how are you going to do that? Alright, now we are going to calculate the E cell. So E cell is equivalent to the E node cell minus 0.059 divided by N log concentration for anode divided by concentration of cathode. Okay, so now your E node cell is the one that you have calculated, 1.10 minus 0.059 divided by n. So what is your n? So n is the number of electron here, so definitely your n is going to be 2 log. So concentration of anode, what is your anode? Zinc, right? So the concentration of zinc is 0.02 molar, and your cathode is the copper, so 0.01 molar, right? So from there you should be able to get your E cell equivalent to 1.0911 volts. So this is the final answer for the last question, which is question 2C. This is the end of this week's video. Thank you very much for watching. I hope by watching this video, you can understand more on how you should tackle all the questions for test 2 questions. So take care, be good, and see you again next week. Goodbye.